Hello everyone. In this video, we will study the control of DC motor speed using pulse width modulation generated by 8051 microcontroller. The aim of this session is to understand why PWM is used instead of direct voltage control and how a motor driver IC like L293D helps safely interface the motor with the microcontroller. Through this presentation and a brief simulation demonstration, we will see how embedded software and hardware work together to achieve efficient and precise motor speed control. Now, in this presentation, we focus on controlling the speed of a DC motor using pulse width modulation generated by 8051. Instead of changing the supply voltage directly, PWM, that is pulsed width modulation, allows us to control speed efficiently. We will also see why a motor driver like L293D is required to safely interface the motor with the microcontroller. At the end of this presentation, you should be able to understand how precise motor speed control is achieved in embedded systems. Now, the 8051 microcontroller operates at a 5-volt logic level and can supply only a limited current of about 15 to 20 milliamperes per pin. Now, the DC motor requires a much higher current and it cannot be directly connected to the microcontroller. Doing so can damage the device. Therefore, external driver ICs are essential when controlling motors in embedded applications. The key features of 8051 include multiple input-output ports, timers, and special function registers that help in controlling peripherals. In this application, port 1 plays an important role by providing the PWM output and direction control signals. The operating frequency of around 11.0592 MHz enables accurate timing, which is necessary to generate PWM signals using software timers. The 8051 controller is widely used in automation, robotics, and embedded control systems where motor control is required. Its ability to interface with driver ICs like L293D allows both speed and direction control of DC motors. The programmable nature of 8051 makes it flexible and suitable for embedded motor control applications. Now let's understand the types of DC motors. We have brushed and brushless motors. In this project, we are using a brushed DC motor, which is commonly used due to its simplicity. The speed and direction of such motors must be controlled carefully depending on application requirements, and this is efficiently done using PWM along with a motor driver. Now, just let's quickly understand the working principle of a DC motor. It works on the principle that a current carrying conductor, when placed in a magnetic field, experiences a force which causes rotation. The speed of the motor is proportional to the voltage applied across it. By controlling the average voltage supplied to the motor terminals, we can control its speed. This concept forms the basis of PWM-based speed control. Now, let's understand why this speed control is necessary. It is very important in applications that require precision and efficiency. Traditional methods like using resistors or linear regulators waste power as heat and waste power as heat dissipation, and it reduces the efficiency. PWM based speed control avoids these losses, improves energy efficiency, reduces mechanical stress on the motor, thus resulting in safer and more reliable operation. Now let's quickly understand the concept of pulse width modulation. Pulse width modulation controls motor speed by switching the supply voltage on and off rapidly. The duty cycle determines how long the signal remains on during each cycle. By changing the on time while keeping the voltage constant, we control the average voltage applied to the motor. This digital method is efficient and generates very little heat. Now, how do we generate this PWM signal with 8051? It is generated by using software. It is generated using software by toggling an output pin with timer delays. Now, timer 0 operating in mode 1 is used to generate precise on and off periods. By adjusting these delays, we can create duty cycles of 25%, 50%, or 75%. The PWM output is given through pin P1.0 to control the motor speed. The duty cycle as seen is calculated by the T or the on time of the pulse divided by the total time of the pulse, that is the T on and T off into 100% to calculate the percentage of duty cycle. Benefits of PWM include it offers several it provides better torque at low speeds and significantly reduces power dissipation. PWM also allows fine and stable speed control with minimal hardware complexity, making it very suitable for embedded motor control applications. Let's quickly look at how we can interface the DC motor using L293D with 8051. In this setup, the DC motor is interfaced with 8051 using the L293D motor driver IC. The driver amplifies the current and protects the microcontroller. The PWM signal from P1.0 is connected to the enable pin of L293D. Let's just see the circuit diagram so it will be clear. So here pins P1.1 and P1.2 control the motor direction through the IN1 and IN2 pins. The power supply connections are done to ensure stable operation. So this is the circuit diagram, and we will shortly see the simulation also. So to view the pulse width modulated signal, we are using a digital oscilloscope as well. Now the program initializes. When we are coding the 8051 to generate PWM signal, it initializes port 1 first for PWM output and direction control. Timer 0 is then used to generate delay based PWM cycles. Different subroutines create PWM signals with varying duty cycles, allowing the motor to run at different speeds. The program runs continuously, demonstrating practical motor speed control using embedded software. Now, a quick check to see whether everything is working all right. You first must verify all the pin connections, ensure that the L293D is receiving proper voltage. As we saw, we are using a digital oscilloscope to check the PWM waveform. Then delay values also can be adjusted to fine tune the motor speed as per requirement. And we must monitor the current flow, which will help in preventing overheating and will ensure reliable operation. So to conclude, PWM PWM-based speed control using 8051 microcontroller and L293D motor driver provides an efficient and reliable solution for DC motor control. PWM minimizes power loss by digitally controlling average voltage, while the L293D protects the microcontroller and supplies the required current. This approach is widely used in embedded systems requiring adjustable motor speed. Now let's quickly have a look at the simulation. Here we have simulated the circuit in Proteus software. Let me just show you. This is the circuit, and here the CRO is showing the generated PWM signal. As you can see, the T on time of the pulse is varying after a certain time, after a certain number of pulses. And here this shows the connection where the 8051 is connected to your driver, and here the motor speed changes depending upon the on time of the pulse. So when the duration of the T on time is less, the motor speed is low. Then when the duty cycle is 50%, it is medium, and when it is 75%, that is the T on time is larger than the T of time, the motor speed is faster.